Hello, my name is Tim Locke. I'm a Senior Solutions Engineer at ParElastic. I really like my job because what we're involved with mostly is supercharging things. I mean, this whole room is all about performance. I love this whole meetup and what it's all about. How many, for us, we focus on one part of the stack. We focus on the database side of it. Is everyone here into the database side of things, of the stack? A lot? Yeah. It's strangely enough, it's the one thing that doesn't scale so well, which you guys all probably know, which makes it a unique opportunity in this space, because nowadays, you know, it's not just big corporations that have big data anymore. Now, all you need is one viral app that you wrote, and now you've got a big data problem. This big data has really changed things. The whole social and media side of things, like Facebook, Flickr, etc. I just came back from Performance Live. Did anybody go to that a couple weeks ago? Performance Live? So you're not that geeks into databases, okay. I got to see some people like Box. Is that the bulb might be going on.
Yeah.
We'll see how long we can make that filament last. From that, no. All right. And we got to see, you know, a lot of these vendors there, like Pinterest was there, Box, Etsy was there, showing some of their work with the MySQL users group and how they solved some of these database problems. Because with all of this now new types of traffic hitting the database, it is no longer just reading. It's not just weather.com, it's also writing. And this is part of the issues with with the operational big data. It's just not large corporations anymore. It's 24/7. You know, it's read and write now. And part of what I want to talk about today is really the writing side of things. So, with MySQL, we have some options in order to up the speed of performance. But when I think of supercharging a database, I look at different ways of optimizing it. You know, what can I do to make it run better in place without adding other kinds of hardware or what have you? So part of this, a couple of meetups ago, there was a gentleman who was talking about caching. That was a really good talk, where the idea is don't let anything hit the database if you can. So you're all familiar with different caching techniques, and memcaching, read this. That's right, it was Dan who did that talk. Another part of optimizing MySQL is going through each one of the parts of MySQL. And I'm not going to go into the details of each one of these, but in optimizing the schema, obviously when you're constructing your data, this is something I used to do for years, is go in and optimize how are you creating your data architecture. Are you using large fields? Are you using small? How are you normalizing it? Are you asking for more data than you really need in some of your queries? Optimizing your indexes. This is all ways of trying to make it go faster, that tier. Query performance optimization is another huge gains if you can write them correctly. How many are involved in any kind of query writing in your apps? Okay, I thought so. So, do you get any kind of feedback from the DBAs when you write some bad queries? Like, do they get any kind of feedback into that iterative loop? You know, yeah. I thought so. That was something I was involved with in optimizing SQL machines is when I analyze the data and all the queries that are coming in, I'd find the bad queries and then have a training session showing how you're almost doing it right, just a little bit different, you know, a little bit of a couple of changes here and there, because, you know, in today's ORMs, it's easy to write and have them generate bad code because it's just an object. I want to pull that object and I want to change one bit in that object and send it back, and sometimes that can generate a lot of bad code. Optimizing the server settings itself to make the engine itself run better is also another option. And you know, with the latest 5.6 in MySQL, they're allowing us a lot finer tuning in being able to handle and manage memory better in mutexes. Scaling up is another option. So essentially, the goal here is in place, after you've optimized it as best as you can, put it on a bigger box, essentially. More CPUs, more memory, use some RAID subsystems. Also, flash and SSDs are now are big in demand. I was talking with the Fusion IO guys at Bracona, and they now have an SSD that is 3 terabyte. It's about $12,000, but that works great. Even the 5.6 version of MySQL is taking advantage of not having to write things. It's random I/O, so they don't have to do lookups and indexing of queries in a way that you know, normally with this you want to keep everything sequential, right? So that the disk head just goes down and reads, and you can now flip a switch, so to speak, in MySQL in the 5.6 version that you don't have to do that, because random I/O can, there's no penalty or very little penalty for that. It costs money. So after you've done all of that, essentially, you know, moving the data around is your next option when you can't get it to go any faster and you still have pressure on the database. One thing that 5.5 has now, actually I think it went back to 5.1, but it's a bit more stable here, is partition tables, where a single table can have partitions and have different files, and you could actually put those on different storage medium, like if you had several different drives on that machine. You could spread those files around, like spreading the love, so to speak. One drawback with those is that still, whenever any query, an insert, update, or even reads, all queries lock all partitions. The 5.5 version now, NODB works with it and will release the lock quickly, just like it does now, but it still is an issue under high volume. Has anybody heard of read-write splitting, or familiar with that anyway? This is one way of spreading the data around. Here you have standard MySQL replication, and I've got 3 or more slaves. And the whole idea is that all reads can be distributed over those slaves. And what that gets you is for applications that are very write light, or I'll say read intensive, that's a good fit. To a point. It depends on a few things, like you can actually do this, you know, go home or back to work and use MySQL proxy and HA proxy to make some of those back-end slaves a read-only slave, and it'll split the queries for you. Problem that you need to be aware of is that, you know, if there is any lag, any delay on a heavy system, you could have some stagnant data. And what that means ultimately could mean corrupted data, because if a query comes in and reads some data that's stale and then goes to write that data before it's been written out, you were corrupting the data. So you need to be really careful of how you apply that, though it does work for heavy read type applications. Sharding. Sharding is another way of dealing with this whole issue, and it actually works pretty well. Places like Box, everybody knows Facebook. This was the only way that they had in order to handle that kind of traffic. I mean, how many servers are they up to in Facebook? Last I heard it was like 4,000, or was it? Yeah, it's pretty crazy. But they didn't have a choice. I mean, that's what they had to do. And if you get to that point where you need to shard, has anybody heard of sharding? In fact, is this, okay. Is anybody here actually sharding? All right. Sounds like a movie. I shouldn't be saying that. Like I sharded just now. Anybody thinking of sharding? Like, anybody feel like the pressure is getting to the point where they are going to have to shard? So you would have had to have done your homework to go into this kind of hell. How was it to shard? Was anybody involved in the sharding? All right. So what was that process like? Was it? I mean, it was not trivial for sure. That's easy. So were you in it from the beginning? In the architecture, or how long did it take you to do it? It's a small group here, so I'm
Yes, so I designed it for Wayfair. And it's actually, the nice thing is it's really super simple at a very high level. The tough part has been the maintenance.
right.
As you bring on new engineers and new features and technologies, maintain, because it's not in a service per se or centralized, trying to maintain kind of that standard over time has been tough.
Right. Now, are you sharding one table? I mean, individual tables, or are you sharding the entire data set?
Yes, entire data set.
Okay. So, and how long do you think that took to implement it?
It was probably like the 3 plus month, 3 to 6 months.
3 to 6 months?
So I will say we did have a couple of tries where it didn't work out.
Right.
So the one that actually worked out, 3 plus months.
Right. And applying what you knew already, maybe some frameworks and all.
SQL Server.
Yes.
Right. Yeah. You had to, right? I mean, you didn't have many options available when you guys were thinking of sharding, right? So,
Depending on alternatives besides sharding.
So we did, NoSQL was kind of just starting to kind of come up at the time, and we were a little nervous about that, and where 90% of our environment at the time especially would have been SQL Server. That was probably too big of a jump. But we've actually, since we implemented our SQL Server sharding, we're actually now trying MySQL Cluster, which gives you kind of built-in sharding. So kind of eliminating the application side, but let the database handle it. And so kind of the jury's out, so far so good, but we don't have a very big
right.
sample size to go on.
Yeah, the whole NoSQL way is, I mean, I've been a database guy for many years, and I count on ACID. I don't want to have to worry about referential integrity. I don't want to have to worry about transactions. I mean, there are many ways or reasons why dropping ACID is a bad idea. So when I think of NoSQL ways, yeah, you can write really fast to something that doesn't doesn't have any of those checks. But I'm not willing, especially in important any kind of financial applications, to drop that. If I do, that means I'm not dropping it, I'm thinking about it. I've got to develop, I've got to design. I mean, how are you guys, you guys rolled your own, so to speak, transactions, cross-shard joins, things like that in order to handle some of this?
So not really. We don't have like a lot of cross-shard joins. There's a couple of times like, admin traffic that needs to be able to do that stuff, but
Right.
It's just a performance killer. So we really try to avoid anything customer-facing, but not do anything like that.
Right, it's physics. I mean, you've got to move data. So anywhere you can avoid doing a cross-shard join, it totally makes sense. But there are times when you have to,
Yeah, what I would say about the NoSQL space is there are use cases for it, but if your use case really requires a relational database, you shouldn't go to a NoSQL approach just because you're of performance challenges.
What I've seen for the NoSQLs, Hadoop and what have you, is, the polyglot kind of a thing, where we've got our main, relational database store, but now we've got these huge files that we want to store somewhere. and maybe we can store those, or media content, streaming, that kind of stuff in these other databases with pointers to it, but it's really kind of a hybrid scenario. So with sharding, it took you guys 3 months, but probably a few months more to come up to speed with doing it. And while you're doing that, you're not developing on the app, right? You're focusing on becoming a database expert. Another kind of sharding is functional sharding, or one of the types is functional sharding, where essentially, and this is many times the next step before you actually shard, where you say, all right, depending on your application, if you can compartmentalize it or have different functions like blogs or forums or, maybe an event type of an app, it can all be together, but all right, all those queries go to that server, and all queries of this function go to that server. And so that's one way of cheap sharding, but it has an end to it, a limit, because again, your blog server, if it blows out, you're out of luck without finding a solution for it. Yeah, it can't scale indefinitely. Another kind of sharding is, I'm bringing back that ugly thing, is the data sharding. Again, it has to be coded within the application. Now, the main advantage of sharding is, when you can't distribute your read queries across, replica slaves. Pardon me. When you can do that, but you can't distribute your writes across those. It all has to go to one, the master slave. And in sharding, you're distributing reads and writes. But when you shard it within the application, then you have to become an expert in databases, architecture, and even parsing. Are you guys doing it in such a way that it's to some degree agnostic, or do all your developers need to know some new language in order to say, all right, this is going to this shard or that shard? Or...
Yeah, no, it's largely agnostic. What we basically came up with is, once you find a customer, you stay in that shard.
Right.
So there's only, let's say, 10 places in our application where we're going to initiate a session where you actually have to find that customer.
Right. And
so there's a couple places where you have to say, hey, I'm going to look here. If I don't find you, then go back and do this lookup to find out where they really would be. But by and large, they're just calling, hey, give me my customer connection, and it knows.
Cool. Right. So you keep all of that customer's data in one shard. Their orders, everything to do with
yes, that. So definitely come up with a sharding key or your sharding scheme is definitely very important.
Right. So then what happens when you need to do some back-end stuff, like what's your out-of-stock situation, or refunding money from different accounts? Those are cross-shard type of operations. That's batch it at night, that kind of a thing, or?
No, so we're using it for our customer and basket stuff. Mm-hmm. And so then anything that we get completed gets into one consolidated order type database. So there's very little of that batch background type process that happens.
Yeah, with sharding, anybody who doesn't know about sharding, basically it's different than functional sharding in that you're sharding most, if not all, of your data, and you're picking a key. You can pick different types of distribution, like random or range. But essentially it is spreading that data. And I'll show you an example later on of a sharding scheme. Some of the things you have to take care of inside of your application is, cross-shard queries generally, unless you can compartmentalize it like in you guys, because it is a problem. But you have to come up with transactions. Transactions work fine if you can keep everything on one shard. And that's probably what you guys are doing.
Yeah, and I will say one of the things that was appealing for us as well is it gave us the ability to put the data closer to the customer.
Right.
So we have multiple data centers. With some like the NoSQL type of solutions, some of them you have some control, some of them don't. Right. So here we technically shard on location. So hey, you're coming from the West Coast, we're going to send to our West Coast data center. You're coming from the UK.
This is GeoDNS type of thing to know where they're from, like if they're traveling. That's a smaller percentage.
Yes. And then so technically we shard on location, but then it's really based on your customer. So anything customer related, and we actually, to give you a good example, we do registries, so that gets even trickier. right? So you could have a registry owner who could get one shard, a registry co-owner who's on another shard, and get the registry buyer who's on a third shard. So keeping track of all your different connections can be tricky, but I mean, it's, once you get it that first time, it's not so bad.
All right, very cool. I mean, so there are definite ways of doing it. How many people are on your sharding team, so to speak?
So it was me and another DBA that kind of came up with most of the design.
Right.
And then we had a team of 2 software engineers that helped kind of backfit the code to work with sharding.
Cool. Would you say it was a good experience, or did it?
Yeah, definitely.
Yeah. Let's see. Shard manage. Yeah, managing it is also a big issue. You know, like moving shards, redistributing. You know, adding shards, and all of that management is also part of the brain trust that you need to pull into your company. This is, you know, my pitch essentially, that sharding, you know, does suck if you haven't done it, you know, and if you're at that place where you're thinking, you know, we can't scale up our machine anymore, we can't optimize it anymore, we've done everything that we can, we're going to have to look at sharding, which is kind of where you guys got to that point. Sharding is this solution that I want to show you. One of the solutions is transparent sharding, where our whole goal has been to have no changes in the app, no changes in your data structure, and we use behind the scenes we use MySQL storage engines. So everything that I'm going to talk to you about in this particular solution is no changes to the app. Okay, the app doesn't have to know about anything that, as far as the application is concerned. You as a DBA or as an ops person will need to know how we're going to shard it, because this is essentially distributing data, and you have control over how that happens. But that's really behind the scenes. The app doesn't need to know that. So it uses the standard interfaces, and with this scenario, you're talking to a MySQL instance, and with ParElastic, it's a database virtualization engine. And so behind the scenes, what we do is everything below here is just off-the-shelf MySQL. It's a fantastic product. It's part of you know, what we went to market with. Our initial prototype worked with Oracle and or Microsoft SQL and Postgres, right? But our go-to-market has been MySQL, and reception has been great. And just going to one of those conferences and seeing everybody that's involved in it is pretty cool. So we rely on that. Our favorite variant is Kona because it's so performant. And so what we do here is, behind the scenes, we'll shard that data table by table on a key. And we've got some patents in this regard that we're not using table lookups. Are you guys doing hash like keys for sharding, or actually you're just doing a customer ID essentially, right? But where that goes on the shard, how is that determined? Is that like a round robin? Or?
Yeah, it's round robin based on location.
Okay. All right. So here you can determine what kind of distribution you want, whether you want to broadcast, meaning I want that table on every, because the goal is to avoid cross-shard joins. So I'll show you an example in a little bit of the different types of sharding that we do. But we're not using any kind of table lookups for this. And we're not using a straight hash. It's an algorithm so that we know exactly where that data is without having to go look for it. Another aspect of this is what we call generation add. I forgot that we changed the direction of this. The generation add here allows us to add, you know, part of the management side of sharding. Can be a pain because when you bring a shard into the fold, many times what happens is you have to redistribute the data. And you know, I'm not sure in your scenario if you have some hotspots, you know, what happens in that location if you have more shards to that. What we can do here is add shards to it, and we don't have to redistribute the data. Any new, say in this scenario, it's customers, any new customers go to there. the existing orders stay where they are. We also have this concept of dynamic processing nodes. So what I like to see, I mean, this whole thing is about supercharging MySQL and trying to get it to go as fast as it can. So the storage nodes, you know, what about letting those do nothing but read and write as fast as they can? You know, not have them do any aggregates, not do any sorting, none of the complex queries. Why don't we have other off-the-shelf MySQL databases handle that? And that is what these are. You can spin these up and spin these down and use it essentially, you know, on demand as you need. And that's part of the whole architecture here. So let me show you a quick example of how this is, and I don't want to over time here. So let's take this case where we've got some data. Looks like I'm missing. I'm just going to show you. Actually, one second. Sorry about this. So I wanted to show you the actual, how it gets from one to another. That's already sharded. This is kind of cool. How long does it take you to bring another engineer into your ways of being? What'd you say?
Arthur might be able to answer better. So we try to create KP articles that, you know, like the basics of, you know, how to work around sharding. And again, it should be largely, you know, visible to most engineers. It's just certain circumstances that you have to kind of be cognizant of what you're doing.
Right. Okay, I'm going to try this. All right, good. All right, so what I'm doing is, let me just show you some instances of like what we look like, and then I want to go into that schema. So, all right, so here's a standard scenario where you've got some number of client browsers, you've got a load balancer, and you've got, you know, app servers that scale, you know, that's the part that scales easily. You can just add more to it. But the MySQL side, you can't scale so easily. We've already discussed some ways of it. In this scenario, I mean, it's just a Java engine that is a parser that essentially takes those queries in and makes some decisions based on where they should go, how they should write, they should read, and distributes the queries over some number of nodes here. And in this case, we fit just fine in the app server layer. In other cases, if they don't want it to be in the app layer, this is also, I'll come back to this in a second, we stand fine on our own. And in this particular case where I showed you some of those processing nodes, because it's physics, right? We want to minimize any kind of network hops as possible. So I can actually have a dynamic processing node right on the ParElastic server there as well, and share these other servers as well. Let me go back. We also have HA availability in this whole architecture, where if any one of those fails, it automatically fails over to one of those replicas. Same thing, any one of the apps fail will continue to run. So that's a strong point. So what I'm going to show you is just how some of these queries work. Since you guys have been working with queries and what have you, I'm going to show you how it flows through that. This is just a simple kitchen utensils kind of a thing, cups and bowls that we're going to sell. And here's the basic order architecture of the schema. We've just got a customer table, we've got an orders table, items table, and you can see customer ID is related to orders, and item ID is in items. Now I'm going to bastardize this a little bit because I'm going to do something with the items table that I never do. I'm going to shard on the item ID. Item tables are usually small enough that I'd want to, broadcast that on every single shard. But in this case, just so I can show you some complex queries, I'm going to do it this way. So I've decided to shard on customer ID, and how I did that was analyzing your data, and we have an analyzer for all the query logs to find out what kind of queries are coming in. And then, we communicate to ParElastic how are we going to distribute this. Like here you can see the customer table is on customer range, on customer ID, and then we've got the orders is on customer ID, and items is going to be in another range, product range on item ID. And so sharded physically, this is what that looks like. Because I picked range, it's essentially a round robin kind of a scenario. So you've got customer ID 1, 2, 3, 4, 5. So you can see how that's being distributed on each of the nodes. The order is the same, but it's not by order ID, it's by customer ID. So that gets me Abel and Fred's orders in one, and you can see that Abel and Fred's orders are there as well. So like I said, each time I have to give the disclaimer because it bothers me, but items, I would broadcast that. So I'd have the whole items table on each one of those. So any kind of queries, like in your scenario, do you have that broadcast? Like you have, so you can do a query that is co-located and everything happens with that one customer?
Yeah, we do it mostly for our static tables. So like our sharding actually looks very similar to this.
Right, okay. Good idea. All right, so let me show you just some of the queries. Familiar website, somebody typed in bowl. That's a horrible query. I would come to your office if I was the DBA. If it didn't have any other filters on it, but we're going to send that. Does anybody have any idea what would happen if I were to send this to a sharded scenario like this? Is it going to hit one of these, all of these?
All.
Yeah, it's going to have to hit them all because it doesn't know. It's not. There's nothing in that where clause that says what key it's on, and so that's in fact what it does. The advantage of this is if this were some table that was, say, a 2 billion record table, well, 1/5 of that is on each one of those shards. So when it goes down there, I know the animation does it in sequence, but it doesn't go in sequence. It sends it to all of them, and it's much only 1/5 of that, and all happening in parallel, much faster.
Do you have any results at some point?
Yes, we do. And aggregated results, anything that needs to be done with that aggregation, say, when I think of aggregation, I'm thinking of counts and things like that. That happens in one of our processing nodes. And like I showed you, go ahead.
Wait for all 5 shots to come back. What happens if one doesn't come back?
If one, well, then if it doesn't come back, then there's an issue with that. It does wait for that last one to come back.
So you will wait for all 5.
So like if something failed on, say, the first one, the whole thing, it'll retry and try and get it. And if it doesn't, and there's might flag a problem with that, and then it'll fail over to the other slave and then pull from that and come back. So this is one of our consoles that you can look into. It just shows activity, and I literally, this is just a screenshot of it, and I've typed in that query and ran it, and we can see what it does and what it returns at the bottom. I keep forgetting the laser pointer or something like that. So here's the scenario where, all right, if you're at this point, hello Timothy, I know who the customer ID is. We're going to do grab everything from the orders, and that's another another thing that I would send you an email on, that get rid of the stars out of your selects. In this case, now without using lookups, we know when we place that data where it is algorithmically, okay? And so we're not querying all the other shards for that, and they're busy processing it. So we're not, we're not spreading that around. And here's what that looks like when we run it. And reports are generally more heinous. This one has only a join in the where clause. So anybody have any idea of which ones this is going to hit? It should hit them all, but in the same case, it's going to hit a fifth of the data. If you pick the right key, and generally, after we've done our analysis, it recommends the right kind of key to go there. So it should be roughly a fifth. So it comes back. I think that's the main advantage, is that you have a much smaller set of data to go through, and all 5 of those at the same time coming back is definitely faster. This is what it looks like with the data set returned. Okay, so here's another local join where if we're looking at the shopping cart, so we're looking at orders or about to order, and we know who it is. So then that's the same query, but I've just thrown in who the customer is. So that really should only go to the one that we know is there. So that speeds those up. So when you do your query analysis, you want to make sure, that you're writing good queries, that they aren't doing big, broad questions that ask for a lot of data. For instance, that last query would never run on a huge data set. And sure enough, that's what it looks like. It's just ables. And so for the ordered result here, I'm going back to that big query that hits all the servers. But because I'm ordering it, again, I only want my SQL servers to collect and write data. That's all I want. So what we do is, in here, and this is the graphic that I'm showing you, but in physics, in real life, we're trying to avoid any kind of hops. That would happen right on the ParElastic server, which has MySQL installed on it as well. So aggregates, that kind of processing would happen there. If we need to do, I'll show you a cross-shard join that's more complex, we have access to any of those, any number of those, and those can be dynamic. And that's what that looks like. These first 5 here are the dynamic nodes, and the last are the persistent sites. So here is a heinous one as well. We're actually not looking by customer ID, we're looking for anybody who has able in the name, and we're going to aggregate it or group it. And in this case, that makes us hit each one of those. It's doing a join on each one of those as well. So now I have record sets coming back. In this particular case, it's going to 5, but it could go to 3. And each one of these are processing that. These have now gone on to continue reading and writing like they're supposed to. And it returns back to ParElastic. So this is lighting up the board, but essentially there's been no change in the code in the app. You didn't have to architect it. You didn't have to change anything about the data structure to worry about that. You manage behind the scenes how you're going to shard it. It's not like you can be unaware. But it's the same thing like supercharging some kind of a car. You've got to be aware of, how to handle a beast like that in the best way with the highest speed, the right kind of fuel, etc. Which is one of the reasons why I like, my job. I want to go into the generation ad just a little bit, just to show you that last part there, what happens with the data there. It's really simple. I've kind of compressed that same data set. So when we add a new data set, any new customers go here, and their data flows into there. So you can just continually add generations, and so you monitor in a regular scenario like your DevOps to see how are those MySQL servers doing. I mean, that's what's so cool about this is that, you know, we're not a storage engine that's special. Is you can use all the same tools. Navio's New Relic is kind of cool to monitor the health of your MySQL servers and tune those. And when they get to a particular point where you think, all right, you know, our data set is growing, you can just add more nodes, and then that flows new customers and their data to the new nodes. I think that's it. Oh, actually, let me go back to the other. Right. I'll skip over this. Does anybody have any questions about that? I'm sure you're dying to ask.
Question.
Shoot.
So let's say I want to do the sharding, right? Do I in the background tell ParElastic that I want to shard by customer ID? So I have to mark a table, someone in ParElastic saying I want to shard by customer ID and give them a range.
Right.
But then how would I talk about all of the child tables?
So let's take that particular case. The child table was like the order table. I mean, in reality, you have an order table, you have a line item, things like that. So what you would do in that scenario is your order table generally has the customer ID in it. And many times the line item table would have a customer ID in it. It would be the same thing you would do with your sharding itself. So you would separate those. So all the line items will show up in the same shard, all the orders.
What happens if the child does not have the customer ID?
So if the child doesn't, you know, that would involve, it could be anywhere, right? So that would be an example of a cross-shard join. So you would see that come in as a cross-shard join, and what could you do to not cross-shard join that? You know, maybe this is business to business, you know, maybe a customer ID is not a good idea because, you know, Walmart is one of your customers. And all Walmart might be going on one thing. You might want to pick another scheme. That's why it's important to decide that, you know, early on, what's the nature of it. It's not that, you know, we can't do cross-shard joins. We do. It's fully ACID compliant. It's not letting go of the relational database at all. But it's physics. You want to, you know, avoid doing that wherever you can. But, you know, it's fully able to run a report on it, you know, and most reports kind of call for cross-shard joins, you know, because they don't care about, you know, where the one customer is. They care about whether the top 10 sales, you know, are you know, it's generally across all of those. So
could I add a shadow column in the child tables that don't have the customer IDs? Add, let's say, a shard ID or customer ID.
You could, but then you just need to make sure that your application maintains that. But yeah, you could do that. It's a shadow in that your application doesn't consume it, but whenever they write to, you know, the items table, they could put that in.
What about the asset property? You said it's asset, right? So what happens if I want to update a bunch of rows and they're across shards?
Wrap it in the transaction, begin, and then put in all your queries, your updates, and then put in a commit at the end. Because if any one of those fails, we roll everything back. So you can count on it.
Is it two-phase commit?
Yes.
It is two-phase commit.
Yep. So, I mean, it would really, you know, say like social gaming is a great fit for this because they could be anywhere. Your friends could be anywhere. And it's fine to start on, you know, say a customer or a user ID. But what if you start messaging between them? You need to be able to do that, or like transactions. You know, sending an item to a friend. You know, you want to, especially if it involves money. You know, you want to be able to just not have to worry about it. I want to be able to say begin. You know, take out and insert. You know, commit, and did it succeed? I don't want to have to think about that.
What really differentiates this from
something like MySQL cluster, or
MySQL cluster, so I went to the Burlington, what was it, the MySQL Tech Tour. And what the reps there were talking about with MySQL cluster is when he showed like the small kind of a application, medium and large, it all has to reside in memory. And to my knowledge, all of the shards, it's all duplicated. So you can write, it's like the multi-master type of a write, but you can write there and it'll eventually propagate over to the other nodes. And the requirements were you couldn't operate it in the cloud because the requirements just between the nodes have to be on their own network, and it's got to be at least a gigabit or more. And when he went to the really large, he showed nothing to do with NDB cluster. He just went to a sharding scenario, which I had nothing to do with. It just blew my mind. I was waiting to hear, what are they doing? But essentially, when you get to those large scenarios, everything has to be in memory. And so when you exceed that, then it kind of falls over there. And that's another issue. That's another characteristic of social media games is that how many develop in Ruby on Rails? No? Okay. Java? What is everybody developing here? PHP? Yeah? Okay. Well, Ruby on Rails uses an active record kind of ORM, and this one app that we were working with, this is the only thing that made any sense, and they had something like 6 blobs in this user record that they were always asking for, and then changing something in that blob, and that blob kept getting bigger, and then he would write the whole record back into it. Poorly designed, but can you imagine from a data flow standpoint what's happening? Looking at the disk I/O on like a New Relic, it was just growing and growing and growing as users started coming in and started going viral. Need to be able to handle that kind of write traffic, even if it's not poorly written. But without being able to shard that and spread it around, you're kind of out of luck.
So what business requirement, or what drove you to try MySQL cluster?
It's similar to what you're saying is the sharding works well for what we wanted to do. Again, it started really simply. There is that kind of maintenance that seems like it could be a headache in the long run. So if you can eliminate that step by going to a database that implements the sharding logic for you. Also, the other benefit that NDB gives us over our own sharding is it gives you the built-in clustering, which we would have to be added as a separate step ourselves. And the other thing that's nice about NDB, and I don't know how it works for you guys, is we haven't tried it yet. So one of the next things on our plate is to be able to do master application. So again, you have one NDB cluster out in one data center, you have another one in another data center, and then do master replication between the two. And again, we're going to basically still shard based on location. You shouldn't get a lot of conflicts.
Right.
Is what our assumption is.
Right.
Yeah, we've had a fair amount of discussions around master application across the availability zones.
That's what we use. I mean, we're very familiar with it. When I showed you like the bottom tier of our HA slide of if any node fails, it's all master replication. So that even that whole process, whatever kind of replication you want to use, if you want to use tungsten, we're not touching that. We're leveraging all the goodness of MySQL and what the community is creating with Oracle. I couldn't believe what Oracle is actually pouring into MySQL. I heard his keynote, and they've got a lot of active developers on this.
Considering the scenario where you compare the single MySQL database with all the tables in one server,
Right.
versus the ParElastic model with sharding and processing blocks. Does the ParElastic process absolutely every possible complex query that runs directly in MySQL natively, or are there any limitations like number of nested levels or?
There's no
expression?
nested levels. So how do I put this? Let's see. There's nothing in the architecture that says, oh well, we can't nor will we ever do that. It would be something that, oh, we haven't gotten that query yet, because and it like correlated. I'm picking one. If we, our complement when we first released and all, it was very solid, very big, and handled all kinds of things. But every now and then we get, some funky query where it's ambiguous, where it's in, I'm trying to remember what this one was, where you really had to do some intelligence on that one clause in the query to know what it is and what it meant. And MySQL lets a lot of things go through without real, strict checking of it. So we need to handle it.
It's not exactly as forgiving as the flat model.
Right.
There are certain limitations.
They're ones that we address and we take care of. But it's not like, we just can't do that.
So what happens
MySQL lets that happen?
What happens when somebody faces that challenge? Do
Well,
they have a way to work around it?
oh yeah. Like in the beginning of this little example, one of the things that we do is we'll take a query log. If we have a day's query log of everything they do, we run it through our analyzer, which is actually a version of that same parser. And if it doesn't like a particular query, we deal with it then. And that's part of the discovery process. It's pretty amazing.
And because of the effort of supporting new features of the next release of MySQL or something,
Right.
how many versions behind do you have to be?
Well, right now we're not 5.6, but we're 5.5, and very few people are in 5.5. New apps and things are in that, and it's just so performant. So we're up with that. So the limitations right now. Right. So views. It's very difficult in a parallel database system to distribute views. Triggers is the same thing. Triggers are difficult, and then store procedures. Even in like Natiza applications, that's difficult. They're using shared something in order to do some of those things, like Oracle is. So those are the three things. That's what I should have said earlier. Views, store procedures, and triggers are. I think of those three, the views would be what we're working on, but it's really difficult to do that in a distributed database scenario. It's just some of the physics of it.
Is this just for new databases, or for example, what if you have already a huge database with several companies?
And it's absolutely for pre-existing databases. In fact, we can function as a replica slave. And so let's say you have a database that is running. We grab the query log and the schema, we analyze it, and we suggest to you what it's going to be, and then we'll take a dump, with a marker, or as though we were going to be a replicated slave. We'll load it into ParElastic and then sync up as a slave, and then you can switch over to us, so you can do it without going down. So it's very much for existing applications.
So, to your example, taking 3 to 6 months, where you talked to Facebook and Etsy and others that have taken much longer than that. And we've done some clients where we've done the analyzation and the distribution in a couple of weeks.
Do you have any benchmark numbers where you take, let's say, one MySQL and you bang away at it until it breaks, and then bring in ParElastic and scale it up? How big can you guys scale that?
Yes, I do. In fact, what I'm doing is I'm going through and testing that on all the different clouds. What we want to do is make this, more available commodity-wise, so that you can spin up instances, because the cloud, I have mixed feelings. There are some good scenarios and not so good
So we can point out that we run in public, private, and hybrid cloud, so working with clients that are in their own data center, so they're not running in a cloud, inspired. And what we found in general is that applications that are running native MySQL, as you increase the load, the currency of users, that at some point MySQL falls off the cliff. And the idea with our architecture is that it keeps going, it doesn't fall off the cliff.
So what's the
So you can
biggest
scale up.
Yeah, what's the biggest use of scale out to? Yeah.
Let's see.
Well, so where we're at, we came out with our first release at the end of last year. And we're in public beta with, a handful of clients, we're putting them into production right now.
So I don't know what
What's the biggest, like, we're working?
Are you talking as in data size, or are you talking about servers?
No, like number of shards.
Number of shards.
How many have you got sharded out to?
Well,
Actually, I have to check with,
Nine.
typically, like when I've been working with all these different cloud providers, and they don't like you taking all of their stuff. So I have sets of 3 and 6 shards, and then I'll have 9 ParElastic servers. So let me go back to,
with the gaming company, we went up to how many, about 10?
to 10, there would have been 18.
nodes, and I had about 10 processing nodes, and then ParElastic was spread across the axis layer, and then I had probably about 10. So you've got an elastic resource in all these tiers.
I think one key is that virtualization layer, right? That's the thing that receives the SQL and decides how to pass out the work, how it goes.
Yeah, ParElastic is software between the application and the database.
Right.
So as the application goes out of queries, it goes through, and that's where, we are seeking the SQL translator to service now.
Exactly.
But the secret sauce in it really is how we distribute the data and how efficient we are at getting at the data. And the fact that you've got an elastic resource that you can actually scale out as you grow, which is more difficult in other architectures. And these processing nodes is something that we haven't seen with any other architectures or any other solutions out there, where you can offload some of the work for cross-shard joins or aggregates or sorts, so that, again, the storage nodes keep working.
Yeah, I'm not quite sold on the processing part of it.
Pardon?
I'm not quite sold on the processing.
I hear you. I wasn't either at first.
Right, like you try, first I think if you're trying to offload the I/O, but I/O usually isn't your biggest bottleneck on DT. Usually processing is not your biggest bottleneck, I/O is. So if you're...
It depends on what it is. So if you're I/O bound,
But what are you trying to do with the processing? Are you trying to offload the
the aggregation, the sorting.
Right, but like, what are you trying to say the regular native MySQL instances from doing?
Complex queries.
The I/O or processing?
Processing, essentially.
Yes, I guess my experience has been that processing is not our biggest bottleneck. It's always I/O.
Well, but it depends on the load. You can have something that's CPU bound, the application.
Usually have a number of CPU bound queries hiding around, like Solar, a number of other applications are CPU bound.
It really did. So what's cool about this is, I brought this slide back up, is we can move it around. So in some of the tests where, say it's just simple types of queries, I can get away with one dynamic processing node on the ParElastic instance, and I don't even need to touch the other two. We have categories of processing. So we have a small, medium, and large. So small would be dedicated to maybe 2 nodes, and medium depends on how many you have. So for the big complex ones, we'll use the whole farm if we had to. So that changes. So let's say you have something that is more I/O bound. Well, I would scale out the storage side of things.
Yes, so the big argument, right? Like, do you bring the processing to the data or the data to the processing? Here you guys bring the data to the processing, right? So if that's a big data set, I don't know, it seems like it could backfire. Like, hey, moving all this data across the network to be processed and then back to, you're just adding an extra jump that, again, I don't know if maybe it does, but.
Well, in one sense, let's say that first ParElastic instance up there. I'm sorry, maybe there is a. that first ParElastic instance there, when, let's say I'm going to do a query across and it hits all of those, but it needed to be sorted. By the time it got to you, none of these are sorting it. By the time it got back to me as the ParElastic instance, I can sort it right here locally and then send it back to the application. So then now the processing on those storage nodes, it's not happening there, right? You know, if you have something that is really, again, it's physics, right? So we want to avoid all kinds of hops. We want to avoid cross-shard stuff. So, you know, if you had something that was very, very I/O bound and had a lot of complex queries, you know, I'd recommend something similar to what NDB Cluster was recommending. I would put the processing nodes on their own traffic-free network that's high speed. So you see the ParElastic layer is essentially processing. You know, every query fires up its own thread and does its own work, and as many as it's given, right? So if you find something that is, say, process bound, I can add as many of those ParElastic layer as I want and scale up that. If I need more throughput as far as data, being able to shard that across, I can add more storage. So I can move things around based on the kind of load. And that's what's kind of cool about the building blocks, like Legos, kind of.
How much overhead do you guys have to experience by using the PE servers? Say, for instance, I have a query that has to be less than 50 milliseconds. Am I going to be able to meet that SLA? Or am I out of luck?
No, if the query needs to be less than 50 milliseconds, you need to look into, we need to see how it's sharded and make sure that if that is your, you know, do or die query, where's that data? You know, we definitely have queries that return. All the sysbench type work that I'm doing has, you know, those 9 or 12 queries wrapped inside of a transaction, and those are all coming back.
Contribute about a third of a millisecond, so about a 1 millisecond overhead reduction just for the network.
So if you're asking something that...
Because you guys are doing single translation, right? Is there anything edited?
That's true.
I missed that.
He's
Sorry.
talking about the SQL translation.
Oh, the parsing, right?
Yeah.
Because essentially we parse the queries and all that. It's very fast. I mean, really, that overhead is probably in that same range of...
Yeah, I mean, we have a bunch of benchmarks that we can share with you that show that we're, you know, basically, we're going to be a little bit slower because of the overhead, but not much. But what happens is as you go further out and the load goes up, MySQL goes up the clip, and ParElastic keeps going. And that's,
Right, so if you were to look at, you know, say, 10 million records that you put on MySQL, it can handle that, right? You can, depending on how big the records are, it can handle that in memory. So if I start upping the concurrency of, you know, how many threads are starting to hit it, at some point it's going to fall over. And especially if it's in memory like that. And where it falls over, we just keep going. Because that 10 million is absolutely nothing. You know, it's separated on 3, you know, ParElastic. I mean, 3 storage nodes. You know, my tests all have been with 250 million. I wanted a real test. I didn't want anything staying in memory. Like in that gaming application, you know, it's not, it doesn't have a chance of caching, you know, that kind of data, those blobs. It's just throwing it into the data, and then at some point, you know, any kind of cache that you have, it's just going to fill up. You know, you can't wait. You know, it's got to spread and go somewhere.
So are you guys competing against traditional scale-up singular instance MySQL boxes, or are you?
What do you mean by that?
Traditional, like, you know, sharding setups. I'm just trying to figure out who's the biggest competitor in terms of ideologies.
Ideology-wise, I mean, what you were saying about MySQL is that scale up, right? You know, some big box that's, so then we come in at a cost point that you know, that big box is costing what, $2,000 a month to run? You could, you know, run this system for far less, you know, because you can add up a bunch of commodity servers and it's spread out wide and much cheaper than, you know, the 64 core, 256 gig, and that's probably going to be even.
So sharding is
doing what Wayfair did is the biggest competition. There's so many people that have sharded, and there's a whole book in Connor's book, that whole chapter on sharding. Sharding takes a long time, it's expensive, and it's hard to maintain. I mean, I don't think anybody would doubt that. So if somebody's already sharded, it's hard to get people to consider this unless they're building a new application, like you're trying out the MySQL situation. There are other sharding solutions out there to try to automate the sharding out there. So that's competition. There's the hardware scenario that you talked about is, the easiest thing is to buy a bigger box, but the cost per transaction actually does not go up linearly when you buy bigger boxes. Or your application, like we're working with a flash sales site, 2 hours a day they get hammered because they put the email out. So they got a problem. They tried to do it with read replicas, and performance was terrible for those 2 hours. So
It's funny to mention because we actually have a flash sales site, we went with Mongo, which again, very similar to the auto sharding and the auto clustering.
Right.
So I've been in the same space as in MySQL clustering.
MySQL clustering would be another alternative.
But MySQL has the transactions, right? That's
Yeah, Mongo doesn't have joins either,
Right.
which can be a good thing. Right.
And if the use case is right for Mongo, I mean, there's services, that's what I said earlier, there's some good use cases. But if you really want a relational database, then your challenge is scaling out. I mean, this is scaling out as opposed to scaling up. It's virtualizing a database here, which hasn't been done. Storage and compute have been virtualized, but the database is a hard problem. That's why this has taken us a while to get to this point, because it's not an easy thing to do, as you can see. But writing code in sharding is not easy either. And sharding is not really a virtualized layer. It's not an elastic resource. You have to do something. You have to write more code. You have to build more shards. It's much harder.
So do you provide any extensibility, like MySQL provides ways to extend certain functionalities? Do you also provide that? Like in case there's a particular feature of certain style of querying that needs to be done, or maybe implement trigger support or something? Would you?
Oh, I see what you're saying.
extensibility?
So we're definitely open to that, we entertain it. Myself couldn't say.
Yeah.
Yes.
So do you actually generate source code for some of the processing tasks, or is it all SQL? And
You mean what comes, so there is nothing on, below this layer here. This is all straight off the shelf. It could be RDS, it could be, we don't have any agents or anything on, this is just straight MySQL. So what these parsers generate is their, MySQL, connects, with MY, the same connection that you have, if I understand what you're saying. So what comes out of those is an actual MySQL connection to MySQL and queries that it understands. And then we maintain state of, transactions.
but the logic to generate those queries and create the
Yeah.
tasks,
That is,
that compiled or?
that's a Java engine.
Java.
Yep. And there's some, we use Hazelcast for, communication between the group. When you go to a multi-mode like this, I mean, you could have a single one, but, that's not, high availability, point 11.1, it's a single point of failure. If you guys know anything about quorum, what have you, need 3. It's just also physics, 3 or more, for them to collude and say, all right, because what you don't want to have is a partition somewhere between that, one is writing unaware of the other one. So quorum is 3 for that. But it's very flexible. Like we did have, this setup, just like this.
So on that cluster there, you said you're using built-in MySQL replication?
Yeah.
Do you have like automatic failover or?
No, that's not from the failover is us, right? So, but the actual replication is just master between the two, or it could be whatever you want. But as soon as I detect that one of those things has failed, I'm going over to the other one.
So you have a process that's doing like a heartbeat type of
Yes.
process.
Yeah, and there's that, but there's also anything that happens with a query, a retry, what have you, then it communicates and then all of them let go and go to the other one.
And my guess is off the shelf as is, you wouldn't support multi-data center because of a two-phase commit, you'd have to do something with the master between the two data centers again.
See, that's something that I'm not up to speed on, the multi-data center, as far as, because that's something, I mean, that is what I believe we do support that away.
Right, but you wouldn't be able to span one cluster across the data center.
Yeah, we are working on that.
Two complete data centers like that, like this system here and this system there. I think we're there for that. But as far as
you could have the two. I mean, basically, it's the same thing that you do to the app layer, right? I mean, the Amazons of the world, they say, well, this is in two availability a little bit something. But if the whole availability zone gets bombed, you have to have a duplicate of everything in the other one, otherwise it's not going to work, right? So, I don't know, there's definitely semantics. Does that make sense? I mean,
I think so. So what you're saying is like you have the ParElastic system here. That's going to be sending us to all of these nodes here that it's managing.
mm-hmm.
But then what happens when you have that same thing over here? Like, right?
Yeah, I was saying,
you have to keep them in sync.
hypothetically, if I had 10 MySQL instances as part of my cluster, and I wanted 5 in Boston and I wanted 5 in Kentucky, my guess is it wouldn't work very well because of two-phase commit. Right? You could do 2 separate clusters that again doing some kind of replication or something, but because of that two, I don't know how you get that to work with two-phase commit.
I need to get back to you on that and talk with engineering.
Are you just worrying about the database here, or are you worrying about everything?
The database too. So if I did it right, and again, I had one cluster that spanned multiple data centers, and I have 100 milliseconds of latency, where you're doing that two-phase commit, like I think your performance would tank. Again, physics, right? You can't.
Yeah, why don't we ask our engineering team about that? We'll get back to that.
And one other question I have is the storage layer elastic? Can I actually remove nodes? Or is it just the processing that's elastic?
No, the processing is definitely elastic. The storage is elastic, certainly in one direction, right? You can add as many as you want. You could, let's say, you're archiving data or deleting, customers. You could move that slice onto some other server that's not being utilized. They're databases. No managing around.
But they might require redistribution.
Yeah, again, one of the benefits of a lot of the NoSQLs is it's truly elastic, right? You can add or take away, and it automatically rebalances the traffic.
I mean, that is something in our future to try to make that easier so it's more automatic. We found that with gaming companies, they have that need because the game is soon it's going to go viral, it's successful, then all of a sudden it starts to wane. So they want to be able to reuse those resources and all that stuff. Yeah. That's the same problem they have with sharding architecture, though. So that's been asked of us as well. So this is good feedback. We do have a free database assessment, so if somebody is considering sharding, we'll actually do the assessment. We'll tell you about a shard, and even if you don't use us, you'll at least get somebody else's perspective or analysis on how to shard data.
Do you guys have any type of demo download or something?
There's a little explainer video on our website, but we don't have that. We can actually give you a demo, but it's not something that you can download. I mean, the demo involves a lot of what we show.
So I'm curious about what ParElastic is going to be going forward. Are you looking to change the feature set, or is the feature set fairly fixed right now, or like?
No, it's definitely not fixed.
So what's on your roadmap?
Just wanted to. We're hiring, as everybody's going, and this is my Bible for sure. I met these guys out at Percona, fire and crew. And as far as those different techniques, I could only just mention them tonight. But if you're involved in any query optimization, what have you, that's one of my favorite resources to use. New features. Right now, we're more instrumentation. We were talking about Chef and Puppet. And, you've got We have more instrumentation. I want to know everything that's going on about the servers. We do have that, like in that console, but from me and my background coming to the company, I want to know more about it, actually running these things. Where's the throughput?
All right, can we get a round of applause for Tim?